Okay, we're working with the Algebra 6.6, and this is going to be exponential growth and decay. And so we're going to look at when things grow exponentially. Bacteria, viruses, spreading gossip or whatever. I mean, things can grow exponentially because one cell happens and then it divides into another cell, and then that divides into two, and that each of those divide into two, so it gets to four. So it grows exponentially. So first off, again, by a graph, it's going to be a curved line like this. It's not going to be linear, and then we're going to learn about quadratics here in the next couple of units. But we have a certain formula that can help us determine the growth and what it's going to be maybe after 5 years, after 10 years, after 120 days. We can figure that out. So what we want to do here is we want to look at this formula here, where y, this is your final amount. Amount. Now your a is your initial amount. How many are you starting with? So initial amount. Now this 1 plus r, this means this 1 is 100%. Then the R is your rate and your growth rate. How is it growing? At what rate? If it's going to be at a percentage, so when we look at like 8% each year, we're going to write the growth rate as a decimal. So it's a percentage, but you're going to write it as a decimal. So we'll do a quick little review on how to do that. And then your T is your amount of time. Is it 5 days, 5 years, 120 days, 35 years, whatever. So your T is your time. Okay. So we're going to look at a few problems. We have an inaugural attendance for an annual music festival is 150,000. So 150,000 people. The first year it happened, this is what inaugural means. First year it happened, 150,000 people. The attendance Y, so the total attendance, increases by 8% each year. So they're going to have us break it down. We want to write an exponential growth function that represents the attendance after T years. So if this festival committee wants to plan and say, okay, in 10 years, how many people should we expect? In 5 years, in 20 years. So they do these things. They have a formula that helps them determine if they have to use the same location, if they have to get a bigger location in about 4 or 5 years. So they can start planning that and thinking about that. So with our formula, we have Y equals, that's going to be our total amount. Initial amount is 150, so this is our A, and then this is our R. So our initial amount is 150,000. Now, the attendance increases 8% each year. So what that means, 8% as a decimal, remember it's percent, which means out of 100. Percent means out of 100. So if you're saying 8 out of 100, well, that's 800ths. You're moving your decimal 2 places to the left. When you change a number to a percent, here's the decimal for 8%, it's 2 places to the left. Okay, so it's going to be 0.8. So you're going to have 1 plus 0.8. Now, the time, we don't know the amount of time yet, but this would be our function. You can even write it like this, 150,000, 1.08. T. So either way, I'm fine with. Now, we want to know about the festival for the 5th year, okay? We'll attend for the 5th year. How many people are going to be attending? Now, they want us to round to the nearest thousandth, okay? Thousands. Not thousandths, but, nearest thousands. Yeah, because they're talking, anyway. So, Y equals, you're going to plug it into your formula, 1.08. The T is going to be your 5th year. Now, when you use your calculator, definitely use a calculator. And you guys, you want to make sure you're using a calculator that you know how to use, not just your computer, because when you take your test, you're going to have a calculator on the computer. But if you can use your own calculator that you know how to use, much better. So I'm going to show you another way. Now, this is the 30x2. The exponent key is here. So this is what I talked about earlier, the caret. So you're going to do 1.08 to the 5th power. Make sure your computer's cleared, or your calculator. 1.08 risen to the 5th power. Now what I like to do is I like to go ahead and write that down in case I made a mistake. Now I'm not going to write down everything there. I'm just going to do it like that. And then you can keep that in your calculator. Times 150,000 equals. So this said 220399. I'm going to round to the nearest thousand. So there's your thousands. So it's about 220,000. Okay. So that's about 220,000 people are going to be in 5 years. If the rate is at 8%, if it's growing at 8%, it's going to be about 220,000. Well, the same venue that I have this at, it might not hold 220,000. So as a planner, I'm starting to look for different places to book. Now, this calculator, you had a caret. This one, if you have an XY here, you do it like, okay, clear. So 1.08. risen to the 5th power. You just have to know how to use your calculator. I always write that down just so in case I made a mistake somewhere I can find it, because I don't know what I typed in my calculator. Now, if it's increasing and you get a decrease, if you get a lower number, something's wrong. All right? Okay, so now let's try this one. If you want to pause it and do it yourself, sure, you can. So a website had 500,000 members, so 500,000 members in 2010. The number Y of members increases by 15% each year. So again, represent rate of growth attendance after 2010. Okay, so after 2010. So our growth rate would be, it's starting at 500,000. Whoops, 500,000. And it's 15%. So remember, it's 1 plus 15% written as a decimal and T years. That would be your equation. Then, how many members will there be in 2016? Now, be careful. 2010 and 2016. How many years is that? Well, that's 6 years. Okay, so be careful there, because this is year number like 0. All right? And then year 1, year 2. So that's going to be 6 years. So your equation is going to be 500 grand times 1.15, because I'm going to go ahead and simplify that, to 6 years. Okay, clear. 1.15. Definitely use a calculator, you guys. You don't want to do this by hand. There's no reason to. 500,000 times 500,000. And always watch, always make sure that I type it in right. I have about 1156530. What is that? Okay, near to the 10,000. 10,000. So here's million. So there's 1,000. There's 10,000. So that 6 is going to make that go up. So it's going to be at 1,160,000 members in 6 years. If the rate of growth, and sometimes it might, it really should probably be an average of 15% each year. Maybe it went up more, maybe it went up less. But this company can give an idea of how many they'd have. So exponential growth, you're growing 1 point something, like 100% and over. This is what your 1 is. It's your 100%. So it's growing 100% plus 15%, not 100%. It's growing at 15%. So you're starting with the original amount and multiplying it each time. So this is why we have a 1.15. Okay. Now, exponential decay. Okay. Now, exponential decay means something is breaking down or it's losing members. So exponential growth, it's the exact same thing except for your formula here. You're going to have 100 minus whatever your rate is. So still, that's your final amount. Final amount. A is your initial amount again, what you're starting with. R is still your growth rate. And as a percent, or as a decimal, now we're going to do something here. You're going to do 1 minus that rate. And then T is your time. So everything's the exact same except for instead of adding to 100, you're going to subtract it from 100. So value of the car. Cars are notorious for losing value over years. That's the thing. When you drive off the lot, if you bought a brand new car, it depreciates and it goes down in value. Unless it's a rare antique. Sorry, I need a drink. Rare antique, then it goes up in value, but otherwise most of the cars, I don't even want a percentage, probably a 98% of cars lose value. Okay, so the value of a car starts off at $21,500. It loses 12% of its value every year. So write an exponential decay function that represents the value Y in dollars after the car after T years. So the value of the car is 21,500. Then it loses. So this is where you have to be careful. You're saying 1 minus 12%, so it's 0.12 t. Now here's what I want you to do. I want you to go ahead and figure what this is. This is saying 100% minus 12%. Well, that's 88%. So 88% as a decimal is 0.88, or 1 minus 12 hundredths. So I like to just figure it out as a percent first and then change it. So this is really saying 21,500 times 88 hundredths t. This is how you know if it's a growth or decay. If it's less than 1, it's a decay. Between 0 and 1, because you can't have a negative, but 0 and 1 is going to be a decay. If it's greater than 1 here, that's a growth. Okay? So now estimate the value of the car after 6 years. So this is what we call just plug and chug. If you know your formula, it's 88 hundredths to the 6th power. 6th power, 88 hundredths to the 6th power. Make sure you have your decimal in there. Okay? So this is going to be 21,500 times 0.464. Even though I write that, I'm going to keep this in my calculator. I'm not going to clear that because that's the most exact I can get. Then times that by 21,500. And so it's about 9. Does it tell me what to round to? It doesn't. So 99846. It says 87. No, you're dealing with money. It doesn't tell me what to round to. Value in dollars. So you can go ahead and put 99845 if you want, or 69. That's going to be the value of the car after 6 years. Okay. And there's other factors, but so it's about that much or around 10,000. It kind of depends on how you want to round it. If there's multiple choice, look for the most exact or whatever they give you, but it doesn't tell me what to round to. Okay, the population of a town in the year 2000, I wrote all over this, is 28,000, and it decreases at a, be careful, at a rate of 2.5 per year. So it started at 28,000. It decreases at a rate. Now, 2.5%. Here's what you can do too. Like I said, 100% minus 2.5%. Well, 100 minus 2 is 98, but you have a half. So that's going to be 97.5. So you can put 0.975. Well, okay, here this would be 0.25 or not 0.975. 28,000. When you change 2.5% to a decimal, there's a decimal there already, but you got to move it 2 places to the left. So you're going to have 0.025. Just make sure I did that right. Yep. And then that, subtract that. Good. It should be y equals. All right, population in the year 2015. It started at year 2000, 2015. That's 15 years. So this is going to be 15 years. So 28,000. I hope you guys can read my writing. Times 0.975. So it's not decreasing very much. So this town's, but it is still decreasing. It's not increasing. And let me do the other calculator just so you guys get used to seeing the different calculators. Okay. So 0.975 risen to the 15th power. I'm going to do that first. 0.684. Now, I'm going to leave that number in my calculator. Times that by 28,000. And now it's about 19,000. Now we're talking about population. So 152, 153. Don't put 1.57. I hate to be that person. That's half there. So you can even do about 19,000 if you want, 19,553. But since we're talking about people, I wouldn't put a point. I hate to be that half person. Okay. Now you're going to decide, is it a growth or a decay, and then solve. Annual I'm going to be ending here. Probably have to do 2 videos here. It's almost 15 minutes. So I'm going to do this next. If you want to go ahead and do it and then check the second video, that'd be great.